This is the Callsun N-type 200 watt ultra efficient solar panel. It comes in a 1-pack and 2-packs. In the past couple of days I've been testing this thing in my backyard. How much power can you get from one of these? It's rated 200 watts. In perfect condition, I think they're actually exceeding the rating on them. I'm going to cut to the video that I've done in the backyard, and then I'm going to come back with some details as far as the construction goes. Okay, so right now we're running on that one over there that is facing the sun. We're going to get a wattage in the Bluette in a second. At 10 o'clock in the morning, 170 watts. That is awesome, right? For 10 o'clock in the morning with a very, very low sun in winter, 180, 170 watts. These panels are rated for 200 watts with the losses in the system, in the wiring, and the fact that it's not perfect day for the sun in the middle of the summer. I think that's excellent. Now we have the other solar panel that is completely flipped. As you can see, it has wires over here in the back, things that will obviously cancel out and reduce the power output because the wires have to go somewhere, right? So I'm gonna plug in the cord and let's see what's gonna happen. We give it a couple of seconds to actually sync up, and it's going to reach its MPPT, and we are already pushing 123 watts, so 122, 24 watts. So obviously there is a difference between that one and this one because the wires and everything else is creating a little bit of a shading, not to mention there is a sticker right in the middle. So awesome results, right? What I'm going to do is I'm going to bring them up, I'm going to lift them up in the air. That way I'm going to give them the best case scenario where you could capture everything that is in the front of the panel, but also some light can escape from the back. Let's see if it's going to change the numbers a lot. Here it is. So right now it's up in the air. I'm literally aiming at the sun and we can see a little bit of a difference. It's already doing 185. So 173 when it's leaning against the wall where there's no light can go in the back. And I just parallel them right now, trying to not shade them in the process. The power bank is reporting 355 watts coming in. Each one will do about 170 right now, and obviously there's some losses in the system. And therefore, at perfect angle, right now I got it as good as I can to face the sun, which is the 10 o'clock sun. We're looking at 380 watts. So they're pushing 380 watts at 10 o'clock, 10:22 sun in the morning. 2 panels hooked up in parallel directly into a battery backup. So obviously there's some losses that this one is reporting. So they are pushing 200 watts easily each. That is quite impressive, I have to admit. This panel are truly 200 watts. Actually, they are running their rated capacity, and I'm not even taking advantage of what they can do in the back, because they're fairly shaded right now. This side of the panel is definitely 200 watts rated. Whatever light can escape over here in the back is going to make a very, very small difference when you are shaded like this. But if you are putting them on some kind of a tracking system, these will even perform better than they are performing right now. So right now we're doing 176 watts. So 1 watt of power does escape in the back. It's very little that can actually get through it. It could go through it right now, but I'm going to move it away from the wall and see what's going to happen. So right now I lift it up in the air and there's just the reflection of the wall, 12 watts. So just the reflection of the wall of the back is 12 watts. Welcome back. So the construction. Well, it's aluminum frame. So it has a black edge aluminum frame with glass in the front. And because they're bifacial, they're not painted in the back. So they're open in the front and they're open in the back. Excellent panels for a tracking device. So if they could do 185 watts in the battery backup, after all the losses in the system, at 10 o'clock in the morning in winter, you're gonna be able to get a lot more in perfect conditions. Also, the huge advantage is that once they're on a tracker, they will expose their back. And then as you saw in the video, it gets about 10, 15, 20% worth of power from the back just from the reflection. The construction is really simple. It does have a couple of sharp edges, so you want to be careful so you don't cut yourself. It's fully automatic. I was talking to the manufacturer before I started a review on this product, and they've sent me some footage. It's quite amazing, the manufacturing process. I'm going to post that video right now. As far as the build quality, they're pretty solid. This edge is rock solid, and this edge is rock solid, and also this one. The back, it's exposed cells with the connectors here in the back. So you have a diode over here and a diode over here that protects the panel from backflow current. You have 8 separate cells. They are parallel to 4 in series that will bring it to 29 volts open voltage, 27 volts working voltage with 8 amps. So I got 8 amps out of them. The connectors are just the normal solar panel connectors. The wires are pretty long. I think that these are quite solid. So if you're in the market for a good type of a solar panel, this will do it. It's the N-type, very efficient, does perform for what it was rated. All I could say is just go for it. I give it 2 thumbs up. Thanks for watching.